Welcome back, my dear students. We are continuing our discussions in the mapping and functions, right? And I hope that you have gone through the videos we discussed in the previous discussions, right? And in case again, I still remind others who have just joined us, right? In case you weren't with us in the previous discussions, you have that chance to use the link down here and update yourself by the previous video, so that what we have now should at least make sense, because you can't just start on the way, you always be puzzled with what we're doing here. Right, please. Right. As for today, that means this video, we are almost in the part of the discussion of the topic. We are just simply going to do some kind of calculations, and the first part of which we are there to work out the values of the range. Remember what we had in the previous video, where we're discussing about the two types of sets that are there worthy for discussion in the mapping and function. We talk of the range and the domain. So you're able to figure out that, say, when we talk of the range, we refer to that particular set, and also talk of the domain, we refer to a particular set. Because what is more involved in the mapping, we are focusing on two types of sets, where we always look at the rank that is associated with them. Right. So we even further went to discuss something about the, what we call it, the function. Right. A function is simply one of the relations of the mapping. And we said these type of mappings are the ones which are expressed as one on two. One mapping. You have to see one member of a range is assigned specifically one member of a domain. So we had a lot in the discussion, and we have some notations presented that manner, things like that. So now here we have got some questions that will be that must be discussed and are related to what we've been discussing about the mapping and functions. So can we have a discussion of the following questions? And these questions are specifically there asking us to work out on the values of a set over a range. So which means you'll be given questions which has got information about the members of the domain, and you'll be asked to work out the values of the members of the other set. Right. So I'll just have only two examples, right? Because we can't have 100 examples discussing of the same thing. What is more important here, can you try to get the knowledge on how simply we can work out the values of a particular set. Right. So I'll read the questions first, and then after we venture into discussion so that we can be fast as much as we are always against time. Right, the first one is the equation which is read, given that f of x is equal to x squared minus 3x plus 4, and the domain is a set described by A which has the following members: -1, 1, -2, 3, and A. They're asking us to work out the value of the range, which is just like the image of the first set, that the domain. Right, and after, what we have to do, we have to present the solutions in the arrow diagram. Right. The second one talks about the speed of an object, that's a particle which have got a mass. So here we're told about the description of the speed of a particular object, that the speed is given in relation to the mass of an object represented by W in grams, right? The formula of which is S of W is equal to 2W cube minus 2 over 3W, right? So we're asked to work out the speed of a particular particle which have got a mass of 1 gram, and the speed for one which has got 3 grams, and the speed for the other one which has got 10 grams. Then at the end, we will need to come up with the arrow diagram that really shows the relationship that exists between the two sets, one about mass and the other one about the speed. Right. So now, by what we have just discussed previously, I hope that now everything here now is simple. You always have at least a picture of what you're going to do in the operations here in order to obtain the set, the other set, and definitely the other set that we're going to obtain here is the set of the image. Like in the second question here, where they're asking us to find out the speed is just giving us the values of the set of the range. The same here, we are there going to wake up the values of the set of the range after we've done operation for these ones here. That's the set, the members of set A. Now, to hand for question 1, we have thus a set A. But first, let us take note of the function. This is the relation and operation x squared minus 3x plus 4. So in this function, you take note that say the variables are represented by x here, that given the expression. So which means in this case, all values that we see here in set A are notations of x. So this is the member of x, x1, x2, x3, x4, x5. We need to connect with what we have been doing previously in the video, so that when we see the numbers, what are they? These are members of the set of the what? Of the domain. So when I'm applied here, what I'll have a group of set A defined by talk of x1, x2, x3, x4. There are 1, 2, 3, 4, and here I've got x5 as the values. I don't want you to do different thing from what we have studied. So you have to define that. So it means the function of which you talk of f of x equal to x squared minus 3x plus 4. Right. So the members as given are -1 for x1 and 1 for x2, -2 for x3, 3 for x4, and a for x, that's a 5. So to find the related members of the other set, which is the range, we can regard that one as set talk of what? That's a set B. What you do, you just have to use this function here, because this one is the one that gives up the relation between the two sets A and B. So what I'll do, I'll have here like say f of x is giving that x squared minus 3x plus 4. Right, now f of x, when the value of a member of the domain is -1. So here we consider that if x is -1, what will be the value of f(x), that is f of x1, a member corresponding to -1. So what you do, you're going to just to process out the -1 in this what we call the machine, operating machine, described by this expression here on the right hand side. So what you have, you just consider -1 as the value of x. So you're going to substitute wherever there is x. So you have like f over -1. It means now we're going to process -1. This is just like an input in a particular machine. So what will happen if this -1 has been processed? So if this one, -1, is put in this machine here, what we'll have is that -1 will be squared, then we subtract the 3 multiplied by -1, then plus 4. That's the way this -1 is going to be processed. So now if the process is carried on, the process, what you expect is the output. That's the first member of the range. So when you can simplify this one, what you have there, we'll get a 1, then talk of the plus 3 plus 4. So that from this one, when this -1 has been processed here, what we get is 8. So which means a member that corresponds to -1, the answer there is 8. So it means -1 is mapped onto 8. Right. Then let us also consider x2, which is a 1 in this case. So if we're there going to process a 1, it will be the same. We need the same machine. So wherever there's x, we're going to substitute with a 1. So it'd be like 1 here, 1 be processed here. It means wherever there's x, write a 1 squared minus 3 product 1, then plus what? Plus a 4. What do I yield here as an output? So what you get here be like 1 minus 3, which is negative 2, plus 4, it gives you a 2. So what I get there is just a 2. Right, that's my product. Again, let us also process up the negative 2. So which means wherever there's x, we're going to write negative 2. So f of negative 2, what we have here is negative 2, that's a squared, minus 3, negative 2, plus a 4. Right. So what do I yield as a product, or say as an output? So here it means we have got a 4 plus 6, 10, plus 4. What we get is 14. So here we have 14. Right? What is it that we're going now to obtain from a 3? 3 will also going to be processed similarly, and let's see what we're going to yield. So 3 is going to be fixed here, so it's just like that. Now we have got f of a 3, like that. So 3 is going to be fixed there. It will be 3 squared minus 3 product 3 plus a 4. What is it that we're going to obtain from here? So we have our 9 minus 9, 0 plus 4. The answer is 4. So here we have got a 4. Right. So you can see what is happening here. This one is processing a particular value and give you the other value as such. Right. Lastly, we have got A. A needs also to be processed, but now A, I don't think is going to give us a specific value. What we obtain from A simply be just like an expression as such. So for x here, we fix A and it will be A squared minus 3 times A plus 4. That's what we have here. And I process A, since A is just a variable, then that is an expression of this kind. So it means the product of A is this expression here, defined as A squared, then minus 3A plus 4 as our product. Right. So this is the way it goes. Right. So we have got set A, set of the domain, and set B as set of the range. So B is an image of A. Right. Now, by the instructions here, we are asked to represent the solutions in the diagram, the arrow diagram. So it is all what we have already done there. We have already talked much about this. I don't think this time around we are having some problems on how we can operate issues about the about the mappings. So what we do there, you just consider the presentation as I can use the 2 lines, like the number lines, or else you can just have the diagrams that's more like spherical, thing like that. So like in this case, let me opt for a spherical type of a diagram, which will look something like this. Firstly, this is my set of A, set of the domain, and here there's another category of a set, which you can describe as the set of a range. This is just like an image of this other set, that is set A. So here we have got B. So members in A, negative 1, 1, negative 2, 3, and A. Members in B, we have 8, we have 2, 14, 4, and then an expression, A squared minus 3A plus 4. That's what we have. So here, what does it mean by the diagram that we're looking for here? It means we need to have to map to say what member is mapped onto what member in B. So we have A mapped onto 8, 1 mapped onto 2, negative 2 mapped onto 14, 3 mapped onto 4, and A mapped onto A squared minus 3A plus 4. Right. So what relation links members in A and B? That can be written down here. So here you say a member, talk of the relation that connects the two sets is a function in X. Right. Meaning what? Is a special relation. That's an onto function. which is defined as what? Talk over x squared. Right? Let me light up here. Light here. You can even light here. F of x equal to x squared minus 3x plus 4. So all the operations that has been carried out to produce this one here were done by this. Right. So that's the way it is. So to find the range, that's what we have done it. You do the operation and get the resultant set. That's the set of the range. Right. Let us now again look at the question B to maximize our knowledge in the mapping and functions. Right. So here we have a function which is represented by a particular formula, which is S of W being equal to the operation that is carried on the W itself, W cubed minus 2 over 3, that is W. Right. So can I just again remove this one? It's distracting us. We already know that we're doing mathematics here. So let's just remove this and light this one no more so that you can be able to see. So you talk of AC of W is equal to 2W cubed minus 2 over 3, then what? W. So here is as good as writing F. So the S has just been used to define a particular function. As indicated earlier, to say the function can be represented using different notations, right? One can use H, one can use F, one can use AC, one can use K. It depends as much as you're going to define what these notations simply means. So every time we see you just writing like say H, and then you write a bracket, and inside you write a particular variable like X, there we will be able to understand that we're talking of what? A function in X. So here the same, when we say SW, we are there going to understand that the S is representing a particular function of W. Right. So it is a function that is going to do the operations on the member that is represented by variable W as such. Now that's what we have here. So what we're given here is just like we have got the first category of values, masses in this case, of different particles, right? So these particles, the masses of these particles, 1 gram, 3 grams, and 10 grams, in this case, can be regarded as the members of the first set, that is the domain. So if I'm going to present them here, I may use a denotation like set of talk of masses. I will present them by M is equal to talk of the first object whose mass is 1 gram. The second one, mass is 3 grams. And the other one, the mass is 10 grams. Right. So what we have in the question is more like we have to find the corresponding talk of a set that maps onto the first one. Right. And this is just a set of the range. Right, of which that set of the range, whose values will be described as the speed. Because what we're working here, we are there going to find the speed of the particles. What is the speed for 1 gram particle, 3 gram particle, and 10 gram particle. So try to understand the speed that we're going to find here. Those are just like members of the other set in our discussion, that members of a range. Right, so what we have here, let us now do the operation and find the speed for these particles. So I'll bring my function down here, which is S of W equal to 2W cubed minus 2 over 3W. Right. For the one, if I would like to find the speed that is going to obtain by a particle whose mass is 1 gram. So what I'll do here, I'll write S of 1. Give me what? It means I'll substitute wherever there's W there, I'll write what? A 1. So here you have 1 cubed minus 2 over 3 multiplied by 1. That's the way it goes. Right. So AW here is just represented as a mass, right? You should also be able to understand the definition of these what? Variables which are found in this expression. So every W here is a mass. So when we look at 1, 3, 4, okay, 1, 3, and 10, these are just like W1, W2, W3. So what we need here, we just need to work out on the F of W1, F of W2, F of W3 by the notation we had previously when I was introducing the functions. So what we get from here, we get a 2, and then what we have here will be like we're going to subtract, that's a minus what? 2 over 3. That's what we have there. So as the mathematician can be able to do the operation of this kind to see the speed that we get from there. It'd be like a 2 minus 2 over 3. You can go and work it on separately. I have got a 2 over 1 minus 2 over 3. Your denominator comes as the 3. 1 here gets 3 times 2 get a 6. And this C you subtract in there minus what? Minus a 4. Because 3 gets a 1. 1 times 2 you get a 2. You get a 4. So it'd be like 6 minus this one. You get what? 2 over 3. So which means what we have here, we'll have 2 over 3 as the speed of this object whose mass is 1 gram. That's what it means here. So it means 1 corresponds to 2 over 3 aside. So 2 over 1, 2 over 3. So you have got this expression, so you can even go through to avoid some errors. Right. So what do we have here? It means if I'm to write somewhere, I need to record that say I have a set here defined as a set of W. Let me just plug this chart out first so that to create more space. Right, so let's have our results indicated somewhere here. Right, so it means the other set, in this case the new set that is about S, I would find it as set S, that the speed, the first speed here is 3, that's a talk of what? 2 over 3. Right, when the mass is what? 1, that's what it means here. When the mass is what? The particle whose mass is 1 gram, it means its speed is 2 over 3. I don't know what measure means. I don't know if it's meters per second. The question has not stipulated in that. But here we're just interested to work out the side. Right. Next value that corresponds to 3. We're talking of an object whose mass is 3. What will be the speed like? By this what? Formula, which is our function. So we're also going to do the same here. Let's say now it'd be like S over a 3, right? Wherever there's the W, we're going to write what? A 3. So it'd be like a 2 here multiplied by 3 to the power 3 minus 2 over 3 multiplied by what? A 3. That's what it means there. So what we have here is just like 2 times the what? We talk of 3 to the power 3, it gives us what? 27. And here what we have is minus 2. So what we get here is 50, 54 minus 2, and the answer of which is 50 what? 52. So which means here the particle whose mass is 3 grams, the speed of which will be 52. I don't know what measure means. I don't know, maybe it's meters per second, whatever. But let's take it, let's say it is 52. Then again, let us also find the speed of a particle whose mass is 10 grams. So for a particle whose mass is 10 grams, what will happen is that this particle will move at a particular speed. And the speed of which it will be like, you still have to take the 10 and process it out in this relation or say operation. So here instead of writing SW, you are going to write S of a 10. So wherever there's W, you are going to substitute for a 10. So here it be 2 multiplied by 10 to the power 3 minus 2 over 3 multiplied by a 10. So when you look at this one, you'll have 2,000 obtained from this one. This gives us what? Minus what? 10 times that one, to of 20 over 3. So you can still more again work out on separately and have that, say, 2,000 minus 20 over 3 is as good as writing that one over 1 if you still want to obtain a single fraction. So the denominator here is 3, and you have got 1 here times this one here, 3 times that one, talk over 6,000 minus 20. Right, so the values of which you talk of the 6,000 minus 20, what you have is just like 5,080. Right, so that's what you have there, divided by 3. So this gives you 5,080 over 3. You can do the operation. This one can divide this one to this one. There's no problem with that. So here, the speed will be worked out on the 5080 over 3, like that. So you can divide the 3 here, no problem, to have a proper fraction aside. Like, so what we have here is that the speeds of which are this one, that one, and that one. So this set is a set of a range. If we are to take ourselves back into what we've been doing about the mappings. Right. Now, since the question is asking us to represent the results in the form of the diagram, then our mind should just be focused on what we have done previously to say what is here is all about the mapping and function. So what we need here to do is just consider the type of the diagram that we have been always being exposed to in the discussion. So here you talk of the now arrow diagram. Is simply a diagram that gives us the link between the two sets. So here a set of a mass and set of the speed. Right, a relation of such kind exists among the members. So here I have got the first set and another set here, the second one. This is the set of the domain, described as the set of the all members, which are W here. Consider these ones as domain, that is mass. And here there's another set of S as the set of the range, that is the set of all the speeds. Light. So here it be like as a light. First set, consider this one as 1, 3, and a 10. Those are masses. The speed of which it be 2 over 3, then 52, then 5080 over 3. So it means 1 gram will correspond to the speed of 2 over 3, and 3 grams correspond to the speed of 52. 10 grams correspond to the speed of 5080, 10. That's 5,080 divided by 3. Right. So the relation bridging the two sets W and S is the function that we have here. That's the SW equal to, you can write that one out, that's the 2W cube minus C 2 over 3 W. That's what we have there. Right. So by this, you know what we're doing here? We're moving stage by stage, a section by section. We discussed what a function is. We've discussed what a mapping is. At least that's the way you should also be able to do as you are revising these concepts. What is it that I'm doing? I need to know what a mapping is. I need to know what type of mappings. I need again to know what type of a mapping is defined as a function. Then thereafter, let us concentrate on the what? The two sets involved in the what? In the function, that the range and the domain. Being the position, how we can find the members of what? Of the what? Of the domain. They're all questions of that kind. Right. So here, that's what we've done here. We have at least get to know the way how we can calculate the members of the domain. Right. So today, that is what we have in this video. Right. The last section is the one that is going to close the entire topic. As I said, we're moving section by section. The last video that we have in this topic is where now we're going to practice on how now we can do the reverse. How can we now find the values of the domain given the value of what? Of the range. Right. Thank you very much for being together. The very last is when now I'll give you an exercise to write, but rather this time I'm around, just get to know about this stuff. It's not all that demanding. Thank you.